So first one is law of gearing or correct condition for correct gearings. This is very important. So here O1 as well as O2 are the two bodies. Okay, two bodies are meet at one point. That point is denoted by capital A. 2 points meet at one point. That point is denoted by capital A. And two body are so shaped, and if they produce a constant angular velocity is denoted by omega 1 as well as omega 2. If they produces a constant angular velocity ratio during meshing, then they are said to be have conjugate action. Then they are called as conjugate action only when the constant angular velocity ratio during meshing. Okay, so when the tooth profiles are so shaped, and if they produces a constant angular velocity ratio during meshing, then they are called as conjugate action. Involute tooth profiles is one in which it gives a conjugate action. So this is called as involute tooth profiles. Let the curve body 1, this is called as one body, this is called as second body, rotating about the center O1. First body rotating about the center O1, second body rotating about the center O2, and two bodies are contact at one point. That point is called as capital A. So here A1 and A2 are the two coincident points. A1 as well as A2 are the two coincident points. A1 lying on body 1. A1 is body 1 and A2 is lying on body 2. Then this is a common point. Okay, common point. Two bodies are meet at one point. Okay, then RQ as well as XY are the XY here common normal line to the point, and RQ is a common tangent line to this point. Okay, next omega 1 as well as omega 2 is the angular velocity of A1 as well as A2. Angular velocity of A1 as well as A2. The linear velocity, it is denoted by VA1 as well as VA2. So VA1 as well as VA2. So this is called as linear velocity of body 1 as well as body 2. So this linear velocity is nothing but this is a perpendicular to O1 A1. So VA1 is nothing but it is perpendicular to O1 A1, and VA2 is nothing but it is perpendicular to O2 A2. Next, so now common normal line, this is nothing but XY is a common normal line which will be cut the line joining the center of two bodies. That is nothing but line joining of two center point is nothing but O1 O2 are the two bodies. So that line joining, so that will cut by normal XY line. That point is called as P. Okay, that point is called as P. So next, common normal intersect the line joining the center of rotation. Common normal line, XY is a common normal line, cut the line joining the center of two rotation. Line joining the center of rotation 1 as well as 2. So that point is called as P, capital P. Next, let O2N. O2N is the common tangent line, is nothing but perpendicular line to the common normal line. This is perpendicular to the common normal line. And one more line, O1M, this is also perpendicular line to the common normal line. So next we'll see. So here from this equation, so if two bodies are to remains in contact, at one point, that point is called as A, then the component of linear velocity VA1 as well as VA2, linear velocity, then component of linear velocity of A1 as well as A2. This is VA1 is nothing but linear velocity of body 1. VA2 is nothing but linear velocity of body 2. Along the common normal must be equal. Along the common normal line must be equal. So that from that expression we can write that equation like VA1 into cos alpha. Cos alpha is nothing but this one is cos alpha, and VA2 into cos beta. So next one, So here, so VA1 we can also write omega 1 O1 A1 omega 1. So VA1 is a linear velocity of body 1. So omega 1 is the rotation of body 1 omega 1 and O1 into A1 and into cos alpha is equal to, similarly VA2 we can also write omega 2 O2 A2 cos beta of body 2. Next, so cos alpha is nothing but adjacent divided by hypotenuse. So here adjacent is O1 M, that is adjacent to this angle alpha, adjacent to this angle is alpha O1 M and divided by O1 A1, that is hypotenuse. Okay, similarly cos beta, here adjacent to this angle is what? O2 N divided by hypotenuse O2 A2. So O2 N divided by O2 A2. Next, here O1 A1 and O1 A1, these two are cancel each other. Here also similar, O2 A2 and O2 A2 cancel each other. Then remaining thing is what? Omega 1 and O1 M1. So interchanging. So omega 1 divided by omega 2 is equal to O2 N divided by O1 M. This is called as velocity ratio. This is called as velocity ratio. Also triangles O1 MP, O1 MP and O2 NP, O2 NP, this O2 NP as well as O1 MP. These two triangles are similar, but it is not a right angle triangles, but the angle is different, but these two triangles are equal, O1 MP as well as O2 NP. These two triangles are equals, that is nothing but equilateral triangle. So from that equation we can also write above equation as O2 N divided by O1 M is equal to O2 P divided by O1 P. Why? Because these two are meet at one point, that point is called as P. Then O1 MP as well as O2 NP, these two triangles are equal, so that we can also write in terms of this equation, we can also write in terms of P. Next, velocity ratio, after changing this, omega 1 divided by omega 2 is equal to O2P divided by O1P. So this is called as velocity ratio. So from this expression we can also tell that thus the law of Gehring state that for constant angular velocity ratio omega 1 divided by omega 2 of two gears, first gear as well as second gears, the common normal at the point of contact of two meshing teeth must pass through a fixed point on the line joining the center of rotation. That point is called as P. So this will state the law of Gehring's. I hope all of you understood this expression. Next, interference and method to avoid interference. So usually interference is nothing but mating of two non-conjugate teeth is known as interference. Non-conjugate teeth is nothing but this profile, the driver as well as driven. This is driver and this is driven. So both are different structure of teeth. Then interference occurs. So if two teeth are overlap with each other, then usually interference occurs. Then how to avoid that interference? So to undercut like this, we can, if you undercut the teeth of driver, then we can avoid the interference. Then usually normal without rotation happens without friction. That is nothing but from in this way we can avoid the interference. Next derivation, length of path of contact and length of arc of contact. So here driver gear is considered as a driven gear and pinion is considered as a driver gear. So pinion is rotating in clockwise direction and gear is rotating in anti-clockwise direction. So externally meshed gear is nothing but both are rotating in opposite direction. So here M as well as n. Mn is a common tangent to the base circle. So this is called as base circle. I will explain about first driver gear. So this is base circle. First this is called as base circle. Then this is called as pitch circle. So pitch circle is usually in between the base circle as well as addendum circle. So the outermost circle is called as addendum circle. Similarly, for driven gears, outermost circle is called as addendum circle. This is base circle, and this is called as this is pitch circle, and this is called as base circle of driven gear. So the driven gear base circle radius is called as R. It is denoted by capital R. Then RA is nothing but addendum radius of driven gear. Addendum radius of driven gear. Similarly, this is phi is nothing but pressure angle. So here also same thing. Phi is nothing but pressure angle. So small r is nothing but pitch circle radius from the origin, okay, of pinion or driver. So RA is nothing but addendum radius of addendum circle of driver gear. So here Mn is the common tangent to the base circle. Mn is the common tangent to the base circle of driver to the base circle of driven. So it is equal to common normal at the point of contact of two teeth. So this will cut the pitch circle point at one point. That point is denoted by capital P. And at the point P, this common tangent line cut the base circles, cut the pitch circle of two teeth. This point is indicated that two circles, two driver as well as driven meet at one point. That point is called as pitch point. So it is denoted by capital P. So this derivation we are going to study in this slides. So first one is O1P. O1P is nothing but pitch circle radius of gear. It is denoted by capital R. So pitch circle radius of gear, and O1E is the addendum circle radius of addendum circle of gear. Addendum circle of gear, it is denoted by RA. Then O1N, that is nothing but base circle radius of gear. So it is also written by O1P into cos phi. O1P into cos phi. Why? Because this is a one triangle. Consider O1PN is a one triangle. From that triangle we can write this also in terms of like this. Okay, is nothing but phi. Phi is angle is here. So cos phi is equal to adjacent divided by hypotenuse. Adjacent is O1P, hypotenuse O1N. So from that expression we can write O1P into cos phi. O1N is also written by O1P into cos phi. So O2P, similarly like this only we can also write for driver gear. So O2P is nothing but pitch circle radius of pinion. So from here to here, this is called nothing but pitch circle of pinion. Next, addendum circle of radius of pinion is, it is denoted by RA, addendum circle of driver gear. And O2M is a base circle radius of pinion. So this is also we can write in terms of cos phi. You consider O2M and P, O2MP, O2PM, that is a one triangle. So this is phi. So phi is nothing but cos phi is equal to adjacent. Adjacent is O2P divided by hypotenuse O2M. So O2P divided by O2M. So from that expression O2M we can also write O2P cos phi. We can also write O2P cos phi. So O2P is nothing but R cos phi. Next, phi is nothing but pressure angle. Next, length of path of contact. So length of path of contact between driver to driven is E to F. E to F is a path of contact. Contact take place between driver to driven gear. That is nothing but E to F. So it is further divided into E to P and P to F. Sorry, here O to M, base circle radius of pinion. So here the adjacent is O to M divided by O to P. So we can also cos phi is nothing but adjacent divided by hypotenuse. So hypotenuse is this one and adjacent is this one to this angle, so that O2m divided by O2p. So O2m is equal to O2p into cos phi. So length of path of contact is E to F, so it is divided into EP as well as PF. So where EP is nothing but path of approach and PF is nothing but path of recess. Then first we find the path of approach. The path of approach is EP. EP is equal to, we can also write in terms of En minus Pn. So we need EP. So EP we can also write En minus Pn. Okay. Next, from the triangle O1 PN, from the triangle O1 PN, so take this triangle. So here is adjacent is O1N, if you want to write cos phi, and hypotenuse O1P. So from triangle O1 PN, so PN is what? Why? Because we need PN as well as EN. So find out PN is what? So Pn is nothing but opposite. We can sin phi. Sin phi is nothing but opposite divided by hypotenuse. So here opposite is Pn divided by hypotenuse O1p. So opposite is Pn divided by hypotenuse O1p. So we can also write Pn as Pn is equal to O1p into sin phi. So O1p we already written. O1p is nothing but capital R into sin phi. Next term is En. So how we can find out En? So join O1 to E. Join O1 to E. Join O1 to E. That is in dotted line, and that is also form a one triangle O1 E and N. O1 E N. That is also form a one triangle. From that we can determine what is En. What is En? From E to N. First draw a dotted line from O1 to E. Then from this triangle O1 En we can determine what is En. So En is nothing but what? So O1 En, that is one of the right angle triangle. So right angle triangle is formula is A square plus B square is equal to C square. So we want En. So that find out En is equal to square root of O1E square minus O1N square is equal to, so O1E we already determined, that is nothing but RA square minus O1N is equal to R cos alpha, so that we can also write R square cos square phi. As per the right angle triangle, consider O1En as per the right angle triangle. So this O1n square plus En square is equal to O1E square. O1E square is equal to En square plus, so O1n square. From that expression we can also write like this: En is equal to square root of O1E square minus O1n square is equal to, you will get this expression. So substitute Pn and En. We already find out En as well as Pn. Substitute back to this equation, then you will get path of approach. So same equation, this equation minus R minus sin phi, you will get path of approach. Similarly, find of path of recess. So path of recess is nothing but PF. Path of recess also similarly find out, that is for pinion. So path of recess is nothing but MF minus MP. So path of recess is nothing but PF. Actually EF is the path of contact. So PF. So how we can write a PF? PF also we can write as MF minus MP. So from that we can determine PF. So from the triangle O2 MP, so this is a first triangle, so that is also similar. So from this sin phi is nothing but opposite divided by hypotenuse. Opposite is MP divided by hypotenuse is O2P. So opposite is MP, hypotenuse O to P. From that we can determine MP. So MP is equal to O to P sine phi. O to P is nothing but small r sine phi. So join next similarly O to B, O to F, you just join like a dotted lines. Okay, from that triangle O to F, that is a right angle triangle. So from that right angle triangle is nothing but so O to M square plus M F square is equal to O to F square. That is actually from that expression you can determine M F square. So what is that? This is a right angle triangle. So O to MF is a right angle triangle. So that O to M square plus MF square is equal to O to F square. So from that we can determine MF square is equal to square root of O to F square minus O to M square. So O to F is nothing but RA square and O to M is nothing but R square cos square phi. So substitute back to path of recess. So path of recess is PF is equal to so MF minus MP. So that equation you just substitute, you will get path of recess. Next combined both path of approach as well as path of recess, then you will get length of path of contact EF. It is a combination of this is path of approach, this is path of recess, along with capital R plus small r combined together, you will get this equation. This is nothing but length of path of contact. Next we'll see the contact ratio. So contact ratio is defined as the average number of pair of teeth in contact, average number of pair of teeth in contact at a time. This can be found by nothing how many times the base pitch fits into the length of path of contact. So contact ratio we can also write length of path of contact divided by base pitch. So that is equal to length of path of contact divided by pi m cos phi. So this is final expression is contact ratio is nothing but length of arc of contact. In terms of path of contact we can also write in terms of arc of contact divided by circular pitch. So next one is minimum number of teeth on a gear to avoid interference. I already told the interference is usually occurs if two driver as well as driven profiles are different. If both are same, then interference not occurs. So if two profiles are different, then interference occurs. Then how to avoid interference? By undercut the teeth we can avoid the interference also. Next also we can also determine the minimum number of teeth on pinion to avoid interference. So here this is the contact point. So here, so this is pinion and this is a gear. Pinion is act as a driver, so rotating in clockwise direction, and gear is in anti-clockwise direction, so that is act as a driven gear. So and here the pinion this is base circle and pitch circle of pinion and addendum circle of pinion. Similarly the base circle of gear, pitch circle of gear and addendum circle of gear. So phi is nothing but the pitch pressure angle. So here M and N are called as interference point. M as well as N are called as interference point. So next one is pressure angle. Phi is nothing but pressure angle. So capital R is nothing but pitch circle radius of gear. So it is also written by M capital T divided by 2. M is nothing but module and T is nothing but number of teeth. Similarly, pitch circle radius of pinion, it is denoted by MT small t divided by 2. So that is nothing but pitch circle radius of pinion. Next, capital T is nothing but number of teeth on gear. Small t is nothing but number of teeth on pinion. So M is nothing but module. So AW, so here written by AW is nothing but addendum constant of gear or wheel. Addendum constant of gear or wheel. So this is nothing but AW into M is nothing but it is a gap between pitch circle to addendum circle. That is difference. So AP is nothing but addendum constant of pinion. So AWM is nothing but addendum of gear after pitch circle. This gap is also we can written as AW into M. And APM is addendum of pinion. APM is nothing but addendum of pinion. So gear ratio we can also written by capital D divided by small t. Capital T is nothing but number of teeth on gears. Small t is nothing but number of teeth on pinion. That is nothing but gear ratio. So next, join O1M. Join O1 to M, that is in dotted lines. And from the triangle O1MP, O1MP. So that is not a right angle triangle or equilateral, nothing triangle. Apply the cosine rules. From that cosine rules, we can determine O1M. So that is nothing but O1M square is equal to O1P square plus PM square minus 2 O1P and PM cos O1 PM. So that is cosine rule. Sine rule as well as cosine rule is there for triangles. So just refer the Google for to find see the cosine rules. So from that cosine rule we can written as O1M square, O1P square plus PM square minus 2 O1P and PM cos O1 PM. So then O1P square plus PM square we can also written as O2P PM square. So PM square is nothing but this triangle. So this is a right angle triangles. So from that we can determine the angle. So that is nothing but phi. Phi is nothing but opposite divided by hypotenuse. Hypotenuse is this one. Sin phi is equal to opposite PM divided by P O2P. So from that expression we can find out what is PM. PM is O2P square into sin square phi. Then O2 O1P and O2 sin phi. PM is nothing but O2 P sin phi into cos O1 PM. Cos O1 PM. This is also we can write cos 90 plus phi. Why? Because phi is here, so that 90 plus phi. So from the triangle O2PM, from the triangle O2PM, so that is nothing but PM is equal to O2P sin phi. So that I already told. So from that this triangle we can determine what is PM. So then O1P square, O1P is nothing, O1P is nothing but R square. That is nothing but it's already written R square. Then O1P, O2P is nothing but O2P. O2P is nothing but small r, R square into sin square phi plus 2r small r sin square phi. Next, same R square you take common, then you will get this expression. R square take common, then from the previous expression, then R square divided by capital R square into sin phi square plus here one numerator 2 capital R into small r, so that one r gets cancel each other. Then remaining is 2r divided by capital R into sin square phi. Next, from that expression, so again you simplify, the square gets cancel each other. Then or else one more way you can do, take r divided by capital R, take common, and sin square phi, so that here so just see these two expression and which one is common, take outside. So here common is small r divided by capital R into sin square phi, that is common, take common outside, and remaining thing is r divided by capital R plus here already taken outside r divided by capital R into sin square phi, so remaining thing is 2. So from that expression O1M is nothing but capital R, so that is nothing but O1M square we actually going to find out. So that take square root outside, take square root on right hand side, then it becomes O1M is equal to, so R square, square root of R square is nothing but R, then whole bracket, you put whole bracket and write like this, half is nothing but square root. Then r is nothing but mt divided by 2, so that you write like this, mt divided by 2 only. Then so g is nothing but capital T divided by small t from the first equation. So you can also write 1 divided by g, and here also 1 divided by g. So next also O1m is nothing but, find out actually O1m is equal to O1p plus addendum of gear. So O1p is nothing but R, O1 plus addendum of gear AW into m, that is nothing but O1m is equal to R, O1p is nothing but R plus AW into m is equal to, R is nothing but mt divided by 2 plus AW into m. So this much area, find out O1m. O1m is nothing but O1p plus P to this area, P to this area is nothing but this O1m divided into, split into 2, R plus AW into m. So next, from equating these two equation, you will this is one equation and this is one more equation. From this equation combined together, O1m is nothing but, this is also O1m and this is also O1m. 1 and 2 equation club together, you will get this equation. Then from that equation find out AW. So AW is nothing but addendum constant. Addendum constant we are going to find out. So how to find out addendum constant? So first this term you move to right hand side. So what happens, entire expression minus mt divided by 2. So here m is common here, so m cancel each other. So AW is equal to remaining thing is t divided by 2, and this expression minus this one, this whatever left hand term is there, that moves to right hand side, so negative sign, minus t divided by 2. So AW we can also written like this from the previous expression. So why? Because t by 2 is common, take t by 2 is common outside, then remaining thing is minus 1 outside. So find out t, the number of teeth on pinion to avoid interference, that is the expression actually. Find out capital T, this is the expression. Rearranging this equation you will get this equation. So 2 into AW divided by, entire this equation goes to denominator, then you can easily find out capital T. Number of teeth on pinion to avoid the interference, so that is nothing but capital G is equal to capital T divided by small t. So from that expression you can determine small t also. So we already learned about three derivations. Now we'll solve some of the problems. For problems, first you going to study the formulas. These formulas is required. This pitch circle radius of pinion, that is small r. Pinion is always small r, and the gear is always capital. So small r is equal to mt divided by 2. T is also small. T is number of teeth. M is module divided by 2. For gears, all are capital. So addendum circle of radius on pinion RA is equal to R plus addendum. So that is nothing but AP into M. So yes, circle of gear RA is equal to R plus addendum. Addendum is nothing but AW into M. So circular pitch PC is equal to, it is denoted by PC, is equal to pi into M. So module pitch M is equal to D divided by T. So for gear, capital D divided by capital T. Diametral pitch PD, it is denoted by PD, is equal to T divided by small d, or capital T divided by D. So base pitch, it is denoted by PB, is equal to pi M into cos phi. So gear ratio, capital G is equal to T, capital T divided by small t. So capital T is nothing but number of teeth on gears, small t is nothing but number of teeth on pinion. So angular speed of pinion omega 1 is equal to 2 pi n1 divided by 60. So angular speed of gear omega 2 is same small n2. The rolling velocity v is equal to omega 1 into r is equal to omega 2 into r. This is nothing but rolling velocity. Sometimes they will tell find out rolling velocity. In that case, you use this relation omega 1 into r is equal to omega 2 into r. So omega 1 of driver, omega 2 for driven. So path of approach, use this formula RA square minus R square cos square phi whole square root minus R into sin phi. So path of recess. So this is formula path of recess, all are small r only. So length of path of contact, it is a combination of path of approach plus path of recess, that is nothing but length of path of contact. Next, length of arc of contact is equal to length of path of contact divided by cos phi, that is nothing but length of arc of contact. Next, contact ratio is nothing but length of arc of contact divided by circular pitch. Circular pitch we already studied in previous slides. So angle turned through the pinion when one pair is in contact. In that case, length of arc of contact divided by 2 pi r into 360 degree, total 360 degree rotation. This is for gear. Capital R is nothing but gear. This is for pinion, small r. Next, sliding velocity at point of engagement. Sliding velocity, sometime they will tell you to find out sliding velocity at a point of engagement. Engagement omega 1 plus omega 2 into path of approach. Just considering path of approach. Sliding velocity disengagement, find out disengagement path omega 1 plus omega 2 into path of recess. Second half portion. This is first half portion. This is second half portion. This is disengagement. This is engagement. Next, sliding velocity at the pitch point. At pitch point, why? Because two gear as well as pinions are contact take place. So that sliding velocity, there is no sliding velocity, just a contact point. So it is written as 0. Next, minimum number of teeth on gear to avoid interference. We already find out with the help of that derivation, that is direct formula. So this is nothing but T. You have to remember this formula to find out minimum number of teeth on gear to avoid interference. So minimum number of teeth on pinion to avoid interference, same, that is capital T, this is small t. So relation is G is equal to capital T divided by small t. From that expression you can find out minimum number of teeth for pinion on rack. So this expression, this is actually usually this type of problem is not usually asked in the exams. So just go through these many formulas. This also just remember these formulas. So length of path of contact for two equal gears. Sometimes two equal gears are used, so that in that case is nothing but driver as well as driven diameter is same, or radius is same. In that case, so length of path of approach is and path of recess is same. So so addition, you just multiply into just write 2. So path of approach plus path of recess, path of approach 1, path of recess 1 is total is 2. So we'll see one by one problems. First problem. So two 20 degree involute spur gear mesh externally and give a velocity ratio of 3 module is 3 mm and addendum is equal to 1.5 module. If the pinion rotates at 120 rpm, determine minimum number of teeth on each wheel to avoid interference, number of pair of teeth in contact. So solution. So first find out minimum number of teeth on each wheel to avoid interference. To avoid interference, we already derived that equation. That is nothing but minimum number of teeth on pinion. They are not asking about gear, so that pinion is nothing but small t. Small t, this is a formula you have to remember. Then what are the parameter is given? So 2 into AW. AW is nothing but addendum. So addendum is equal to 1.1. So here they taken 1, no problem. And G is gear ratio is 3 mm. Gear ratio, velocity ratio, it is also given as velocity ratio. So velocity ratio is 3. So 1 plus 1 divided by 3 sine square 5. Angle is given, that is 20 degree, and plus 2 this is find out, you will get small t is 16.48. Next, once you find out minimum number of teeth, you can easily find out minimum number of gear, number of teeth on gear. So how to find out? So this is close. Why? Because the teeth are not in fraction, so that you just take approximate number close to that number. That is nothing but 16.48 is nothing but 17. Then find out capital T. So how to find out capital T? G is known. So G is equal to capital T divided by small t. From that we can determine capital T is equal to 51. Next, second sub question, number of pair of teeth in contact. So in order to that, we have to find out pitch circle radius of gear, that is capital R is equal to mt divided by 2. So T we already find out, that is 51. M is module is also given in the question, into 3 divided by 2. From that we can determine capital R. Next, addendum circle radius of gear. Circle radius of gear, that is RA is equal to capital R plus addendum. Addendum is nothing but AW into M. So AW is 1.1 into M. M is 3. So 1.1 into 3 is 3.3. So R is 76.5. From that expression we can determine RA. So RA is equal to R plus addendum. So pitch circle radius of pinion. Similarly, we have to find out for pinion, small small r is equal to mt divided by 2. So from that we get r is equal to 25.5 mm. So addendum circle radius of pinion, RA is equal to R plus addendum. Addendum, that is same. Addendum value for gear as well as pinion is same always. So from that we are getting RA. So from that, length of path of contact formula, this is length of path of contact formula, path of approach plus path of recess. So from that this one we can determine length of path of contact. So substitute all the value RA and R and small RA and R. So phi is also given, phi is 20. So from that we can determine the length of path of contact. The length of path of contact is 15.737 mm. So next find out length of arc of contact, length of path of contact divided by cos phi. So from that we can determine length of arc of contact. Length of arc of contact is 16.747 mm. Next, contact ratio. Find contact ratio. Contact ratio is nothing but length of arc of contact divided by circular pitch. So length of arc of contact is 16.747 and divided by circular pitch is how much? Pi m. So from that we can determine contact ratio. Contact ratio is 1.777. So it means that there are alternately one pair and two pair of teeth in contact, and one on a time basis is average is 1.777. So we'll see second problem. Second problem is the standard full depth 14.5 degree gear, 14.5 degree gear, previous one is 20 degree gear. So 14.5 degree gear have a module M is 5 mm and pinion has 15 teeth and gear has 60 teeth. Addendum is 1 module. Show that the gear will interfere with the pinion. Interfere is nothing but contact. Should the pressure angle be increased to eliminate the interference? These two we have to find out in this problem. So first find out capital G. Capital G is nothing but T divided by small t. So that is nothing but 60 divided by 15 is equal to 4. So addendum is nothing but AW into M. AW is 1 into M. Module is given. So module is given. Modules I think 1. So AW is equal to 1. For the gear ratio 4, phi is equal to 14.5. So from that expression you can determine T is equal to, we can easily determine T. So all data we know. So AW is equal to 1 and G is equal to 4. I think here module is 1. Okay. So when the module so here that is directly given, so addendum is equal to one module, so that is already given. So from that we can determine small t is equal to 29. So module is 1, so module is 1, then AW is equal to 1. So small t is equal to 29. So as the given number of teeth on pinion 15, so pinion teeth is given 15, less than the minimum number of teeth on pinion to avoid interference, 29 interference will occurs. So actually if you are going to find out, you will get 29, but actual teeth is 15 teeth, so that should be less, you should get less than the actual teeth. So this is one is 29 interference will occurs. If more than 15 teeth having pinion, then interference will occurs. So when the number of teeth on pinion t is equal to 15, then let's the pressure angle, find out pressure angle. So reverse calculation, you have to do reverse calculation in order to find out the pressure angle. So like this, so here t is 15, then 2 into 1 and 4, everything data you find out, then you will get 5. 5 is unknown, is nothing but 5. Find out 5, then you will get 5 is 20.31 degree. Therefore the pressure angle should be increased to 20.31 degree from 14.5 degree. Then you can eliminate the interference if t is equal to 15 and capital T is equal to 60. Understood? So the actual pinion teeth is 15 teeth. Once you find out t, you will get 29, so interference occurs. So you change the pressure angle. Should the pressure angle be increased? Yes. Final answer you should give yes. Pressure angle should increases from 14.5 degree to 20.31 degree. We'll see next problem. Two equal spur gears of 20 degree in involute teeth module, pitch 4 mm and number of teeth 40 are in mesh. If the length of arc of contact is given, arc of contact is 1.75 times the circular pitch, that relation is given, find the length of the addendum. So given data is phi is given, capital T is equal to small t is equal to 40 m. Why? Because so the two spur gears are equal. So then length of arc of contact is equal to 1.75 times of circular pitch. Circular pitch we can denoted by PC. 2 equal spur gear. Pitch circle radius of gear, capital R. First to find out capital R, formula is this one, mt divided by 2. So from that we can determine capital R. Then length of arc of contact, this relation, using this relation, PC is equal to pi m. M is nothing but module. So from that expression we can determine like this, 21.99 mm by substituting the values. So here module pitch is given, that is 4. By substituting this we can determine the value of length of arc of contact. Then length of arc of contact is equal to length of path of contact divided by cos phi. So from that expression, so phi is already given, so from that expression you can determine length of path of contact. So length of path of contact is 20.66 mm. So using this expression, reverse calculation, length of path of contact we know, from that we should determine capital RA. So this is 2 times of RA square minus R square cos square phi square root of this one minus R sin phi. Why? Because here we know the sin phi, we know, find out capital RA. Why? Because two spur gears are equal, so that here this formula we should use. From that expression we can determine RA, that is nothing but length of addendum. So addendum is equal to, so RA minus R. So R we already determined, so from that already known, from that we can determine addendum. Addendum is 4.09 mm. So next problem, the following are particulars of a pair of spur gear The number of teeth on pinion is given, number of teeth on gear is given 47, pressure angle is given, module is given, addendum is given, determine number of pair of teeth in contact and angle turned through by pinion and gear when one pair of teeth is in contact, and ratio of velocity of sliding to rolling velocity at the instant the engagement begins and engagement terminate at the pitch point. These three parameters we have to find out. So capital T is equal to 47 is given, small t is also given 19, pinion teeth, and pressure angle is given, that is 20 degree, addendum is given 6.5 mm and the module is 6.5 mm. The pitch circle radius of gear capital R we can determine using this formula. Next, pitch circle radius of pinion, that also we can determine using this formula. All data is given. So addendum circle radius of gear RA, capital RA is equal to capital R plus addendum. Addendum is nothing but AW into M, that is also directly given, so no need of multiplying. So is nothing but addendum is directly given AW into M, so M is 6.5, so addendum is 6.5 mm, so AW is nothing but 1, so AW into M, addendum is nothing but AW into M, so 6.5 into 1, AW is 1, so that 6.5, so you will get addendum circle radius of gear capital RA. So addendum is directly given, no need of finding anything. So next, small RA. So addendum circle radius of pinion, small RA is equal to R plus addendum, so that is nothing but you will get this answer. So length of path of contact using this formula, this is two spur gears are not equal, so that using this formula and find out length of path of contact, or data is given here, using that you can find out length of path of contact. Phi is given, that is 20 degree, so you will get 31.542 mm, that is length of path of contact. Next, length of arc of contact is nothing but length of path of contact divided by cos phi. From that expression you can determine length of arc of contact. So next, number of pair of teeth on contact. Number of pair of teeth on contact, that is this formula, length of contact ratio, it is nothing but, so length of arc of contact divided by circular pitch. Circular pitch formula is pi m into 360 degree, one full rotation. So that is length of arc of contact from the previous slide, that is 33.566 divided by pi m. So m is also already given. From that expression you can determine the number of pair of teeth in contact. It means that there are alternatively one pair and two pair of teeth in contact, and one time basis the average is 1.6444. Then angle turned through by gear when one pair of teeth is in contact. So that is nothing but length of arc of contact divided by 2 pi r. The angle turned through one gear when one pair of teeth is in contact. One pair of teeth is in contact. That is, this is formula 2 pi r into 360. One pair of teeth, find out in one pair of teeth. So length of arc of contact is 33.566 divided by 2 pi r. R is also we find out using that formula, m capital T divided by 2. So from that we can determine. Then angle turned through by pinion when one pair of teeth is in contact. Similarly you can find out, but here small r, not capital R, this is small r, so small r value, then you will get for pinion, one pair of teeth is in contact in pinion, that also we are getting. Then rolling velocity, I already told, so rolling velocity is nothing but you should use this expression, omega 1 into r is equal to omega 2 capital R. So from that expression you can determine, you can tell that omega 2 is equal to omega 1 into small r divided by capital R. So path of approach, find out separately path of approach formula, you already know. So RA square minus R square cos square phi, square root of this thing, minus R sin phi. So using that all data you knows, based on that you can determine path of approach. Similarly path of recess, this is a formula, substitute the value and find out the answer, path of recess. Next, this is a formula. Find outing sliding, they told you to find out sliding velocity at instant engagement begins. Engagement begins, for this is a formula, omega 1 plus omega 2 into path of approach divided by rolling velocity, formula is omega 1 r. So here just substitute in terms of omega 2, you just substitute omega 1. Omega 2 is equal to omega 1 r, small r divided by capital R from the previous slide. So into path of approach, so just substitute the value here. Omega 1 take common outside, so 1 plus, so r small r divided by capital R into path of approach. That also we have to find, find in the previous slide. So just substitute omega 1 cancel each other, you will get the answer. Next, similarly path of recess. So this is already done. So sliding velocity at instant engagement terminates, this is engagement begins. Next to find out engagement terminates, that is also same thing, but path of recess. So here also same thing. So write omega 2 right in terms of omega 1, then that to cancel each other, but here capital R, this is small r, that is the difference. Here also small r, this is also small r. Difference is path of approach as well as path of recess. For engagement path of approach, for terminates path of recess. Then you will get the answers. So then sliding velocity at pitch point. Pitch point there is no sliding point, so that answer is 0. Next we'll see the next problem. A pair of spur gates has 16 teeth and 18 teeth. A module is given 12.5 mm and addendum 12.5 at a pressure angle 14.5 degree. Prove that the gear has interference. Determine the minimum number of teeth and the velocity ratio to avoid interference. So addendum of gear is nothing but AW into M. So AW is not given, but addendum is directly given, that is nothing but 12.5 mm is nothing but AW is nothing but 1. So find out AW. So addendum of gear, addendum is directly given and module is also given. You can easily find out AW is how much. AW is 1. Then gear ratio is equal to capital T divided by small t. So both data is given, so that from that you can determine gear ratio. So capital T formula is this one. Find using this you can determine capital T as per the given data. First, so G is given, phi is given, and AW is 1. So from that you can determine capital T. The given number, the given actual number is how much? 18 teeth. Of gear teeth is how much? 18. So they told you to find out what? Gears. Prove that the gear have interference. So gear teeth is how much? Gear teeth is 18. So here the teeth is more than the required teeth, so that what is next step? So you just change the gear ratio. So just change the gear ratio. If it is 27, then 25 is nothing but 26. 26 is nothing but gear ratio is how much? 1.125. You should get t, small t, in terms of not in terms of fraction. So in such a way that you take t is 27, or else you can take t is 26 also, but if you taken 26, then small t you will get in fraction. So to avoid that one, you take 27, then t small t you will get 24.